Welcome to Venus, a scorching hot landscape often referred to as Earth's twin, but in reality, it is nothing like our home. Your mission is to experience this harsh environment for just 5 seconds, which may feel like an eternity. Venus is our closest neighbor in space, located approximately 40 million kilometers away from Earth at its closest approach. After 4 months of space travel, you will finally have the opportunity to observe this beautiful yet treacherous planet up close. Venus and Earth were formed in the same area of our solar system around 4.5 billion years ago. Just like Earth, Venus is a rocky planet and shares a similar gravitational force. However, the surface conditions on Venus are extremely hostile. We have gathered information about this through various probes that have been sent to Venus. Some of these probes orbited the planet, some performed flybys, and a few even successfully landed on its surface of Venus, but those didn't last very long. What happened to them? Well, that's what you're about to find out. Time to make your way down to the surface. Don't these clouds look beautiful? Well, don't inhale them. These yellowish bands streaking across the sky are clouds of sulfuric acid. If you could only get a whiff of them, you'd smell the reek of rotten eggs. But to do that, you'd need to remove your helmet, and I definitely do not recommend that. At a height of 50 kilometers above the surface, visibility is poor. You'd hardly be able to see anything. The incredibly thick atmosphere would block views of this planet and its tens of thousands of volcanoes. The atmosphere is mostly made up of carbon dioxide, and because it's so thick, it traps heat on the planet's surface, keeping it nice and toasty. Just how toasty are we talking? Oh, you're gonna find out the hard way as you descend another 15 kilometers. The haze would begin to clear. The world below would finally reveal itself, a rust-colored surface covered in mountains and volcanoes. Looks like this volcano is still active. You'd fly around a little to collect some samples and take in the view. Yep, the atmosphere is mostly carbon dioxide, with traces of nitrogen. That checks out okay. Well, let's see if you can land here. This looks like the spot. Looks like there's no signal initiating the landing sequence without clearance. Fingers crossed. Landing your spacecraft would kick up clouds of dust that would take several minutes to settle down in the soupy atmosphere. As it clears, you'd look up into the sky, but you wouldn't find the familiar yellow circle of the sun on Venus. It always looks like dawn, no matter what time of day it is. That's because the Venusian atmosphere only lets about 10% of the sunlight that hits it reach the surface. What were we saying earlier about the space probe that landed on Venus? Oh yeah, Venera 13. This Soviet probe made its fatal landing back in 1981. It survived the descent and lasted for a hopping 127 minutes. That's longer than any other spacecraft that had made it to the surface. But then Venera 13 gave way to the violent, uninviting environment of this hell. It was likely crushed under extreme pressure, or it melted, but it's too late to turn around now. You've lived through the 1-hour-long landing, and you're so close. All you need to do to complete your mission is to spend 5 seconds out there. Hey, yeah, out there in the most extreme environment you've ever been to. Foreign. Whoa, the atmosphere is so strange you can hardly lift your arms. Even though Venus has about the same gravity as Earth, you'd be feeling the sheer weight of its immensely dense air. It would feel like you were walking through water, very hot water, and you'd be glad you were wearing so much protective gear. A quick look at your thermometer would tell you that it's a sweltering 475 degrees Celsius out here. That's hot enough to melt lead. Your pressurized suit would be working hard to keep you safe. Without it, you'd be crushed under all that pressure before you could even complete your mission. This isn't so bad after all. Hey, if a spacecraft could last over 2 hours some 40 years ago, well, you and your shiny new gear can survive longer, right? Venus is right here for you to discover. Just take a few more steps. Suddenly, something distracts you from the first-hand human analysis of Venus's surface conditions. Your protective suit breaks. The drastic pressure shift would immediately make you feel like you were deep underwater with an atmospheric pressure 90 times that of Earth. Venus would be crushing you from all directions. At the same time, you'd be struggling to breathe in an atmosphere without any oxygen. Any atmosphere you did manage to inhale would scald the inside of your mouth and the top of your throat. Unless you could scramble very quickly back to the safety of your spacecraft, you'd be dead within seconds. Hey, it could be worst. High above you, sulfuric acid clouds would be raining acid, but in this unbearably hot environment, the toxic rain wouldn't reach the surface. It would evaporate long before that, so at least you wouldn't have to worry about acid dissolving your skin and bones. That would be kind of gruesome, you know, in hindsight. Maybe we shouldn't have sent you down to explore this hellish surface. We probably should have terraformed Venus. I understand your curiosity about the potential continuation of the text, but it is important to note that terraforming Venus into a more hospitable planet is currently beyond our technological capabilities. Venus is an extremely challenging environment, with a thick atmosphere composed primarily of carbon dioxide and temperatures that can melt lead. The lack of oxygen and the intense pressure would make it impossible for humans to survive on the surface without extensive protective gear. In the meantime, unmanned missions to Venus can continue to provide us with valuable information about the planet's unique characteristics. These missions can focus on studying the atmospheric composition, weather patterns, and the potential presence of volcanic activity. By analyzing the data collected, scientists can gain a better understanding of the planet's history and potential habitability. The exploration of Venus also holds significance in our search for extraterrestrial life. While the surface of Venus may not be suitable for life as we know it, there is a possibility of microbial life existing in the planet's atmosphere. Studying the composition of the atmosphere and conducting experiments can help us determine if life exists or has ever existed on Venus, providing insight into the broader question of the existence of life beyond Earth. Additionally, advancements in remote sensing technologies can enhance our ability to explore Venus from a distance. These technologies, such as improved imaging instruments and spectroscopic analysis, can provide detailed information about the planet's surface and its geological processes. By refining these techniques, we can uncover more about the planet's geologic history and potentially discover new insights into the formation and evolution of rocky planets like Venus. In conclusion, while the surface of Venus remains inhospitable to human exploration, unmanned missions and remote sensing technologies are vital tools for expanding our knowledge of this fascinating planet. By continuing to explore Venus remotely, we can unlock its secrets, deepen our understanding of planetary processes, and pave the way for future scientific advancements in space exploration. In the meantime, unmanned missions to Venus can continue to provide us with valuable information about the planet's unique characteristics. These missions can focus on studying the atmospheric composition, weather patterns, and the potential presence of volcanic activity. By analyzing the data collected, scientists can gain a better understanding of the planet's history and potential habitability. The exploration of Venus also holds significance in our search for extraterrestrial life. While the surface of Venus may not be suitable for life as we know it, there is a possibility of microbial life existing in the planet's atmosphere. Studying the composition of the atmosphere and conducting experiments can help us determine if life exists or has ever existed on Venus, providing insight into the broader question of the existence of life beyond Earth. Additionally, advancements in remote sensing technologies can enhance our ability to explore Venus from a distance. These technologies, such as improved imaging instruments and spectroscopic analysis, can provide detailed information about the planet's surface and its geological processes. By refining these techniques, we can uncover more about the planet's geologic history and potentially discover new insights into the formation and evolution of rocky planets like Venus.